Let's start with AND gates. This particular one is a dual input AND gate, which means it has two inputs. There will always be a single output on all of these gates. There is also a tri-input, a quad input, and so on. And each one of these inputs is exactly the same thing as a contact in a series circuit. We're going to use these graphics to explain exactly how the AND gate works. If you look at the first graphic, which is right above my head, you will see that there is a series circuit there. It has two set of contacts. If you look at the AND gate, which is immediately to the right of that, then you will see it also has two inputs. Each of those inputs is the equivalent to one of those contacts. And if you look immediately to my right, you will see there is an AND gate truth table. It explains exactly how the inputs and outputs relate to one another. If you look at the first line in the truth table, you will see that input 1 is low, input 2 is low, and output is also low, which means that you have 0 inputs and you have 0 output. Now let's take a look at the second line on the truth table. It says that input number 1 is 0, which means it's low. It says that input 2 is 1, which means it's high, and the output is still 0. So if you look at the drawings above, you will see that the number 2 contact is closed, and there is a hot input going into input 2, which verifies the truth table. Now let's take a look at line 3 of the truth table. It says that input 1 is high, input 2 is low, and there is no output. And if you look at the drawings, you will see that means that the number 1 contact is closed, and the input on the AND gate number 1 is also hot. But you still don't have an output because it's the equivalent to a series circuit. Okay, now let's take a look at line 4 of the truth table, and it says if input 1 is high and input 2 is high, then we have an output. And if you look at the drawings, you will see that contact 1 is closed, contact 2 is closed, which allows a path to give you an output. If you look at the AND gate drawing, you will see the same thing. If input 1 is high, input 2 is also high, then it gives you an output, which is exactly the same as any standard series circuit. Next, let's take a look at a NAND gate, which means a not AND. If you look at the symbol, you will see there is a small circle prior to the output. That small circle means that if it's low coming in, it's high going out, just like an inverter. And if it's high coming in, it's low going out. So it is inverse to what you would normally have. Let's take a look at the truth table for the NAND gate. If you look at the first line, you will see that 1 is high in this particular situation, because in a normal AND gate, if both of those were low, you would have a low out. In this case, we have a NAND, which means it inverts the signal. Let's take a look at line 2 of the truth table for the NAND gate. Input 1 is low. Input 2 is high. The output is also high. If it was an AND gate, it would be a low output. However, it inverts the signal. Therefore, you have a 1 output. Okay, let's take a look at line 3 of the truth table. You have input 1 is high, input 2 is low, and the output is high. Again, it inverts the signal going out. Okay, let's take a look at line number 4. The input 1 is high, input 2 is low, but the output is low. Again, it's just inverse of an AND gate. Okay, let's take a look at an OR gate. If you notice, the symbol is somewhat different. The line on an AND gate is straight where the inputs are, and on an OR gate where the inputs are, there is a curved line, a concave line. Everything else is pretty much the same on the symbol except for the line on the input side of the OR gate. And an OR gate is an equivalent to a parallel circuit. We know from our past lessons what a parallel circuit is. Okay, let's take a look at the truth table for an OR gate. If we look at the first line, we have a 0 input 1, a 0 on input 2, and there is a 0 on the output. So that means low for input 1, low for input 1, and low for the output, which makes sense for a parallel circuit, because if neither of the contacts on a parallel circuit are made, then we have no output. Okay, if we look at the truth table for line 2, it says input 1 is low, input 2 is high, and the output is also high, which would make sense for any type of parallel circuit. If either of the contacts are made, or if both of contacts are made, then we have an output. Okay, line 3 says that input 1 is high, input 2 is low, and the output is high, which again makes sense. If either of the contacts are on, then we do get an output. Line 4 of the OR gate truth table says that input 1 is high, input 2 is high, and the output is also high, which of course makes sense. If both of those contacts are made, then we will most assuredly have an output. Okay, let's take a look at a NOR gate. A NOR gate is a not OR. And if you look at the symbol, again, there is a small circle on the output end of the symbol, which means that it inverts whatever the signal is coming out. Okay, if we look at the truth table again, it's going to be the inverse of an OR gate. So if you have nothing or 0 on input 1, 0 on input 2, then you have a high on the output. Line 2 of the truth table shows us that input 1 is low, input 2 is high, and again it's an inverse of the OR gate, which would be a low output. Line 3 shows us that input 1 is high, input 2 is low, and again inverse, so the output would be low. Line 4 of the truth table shows us that input 1 is high, input 2 is high, and again inverse, which means the output is going to be low. Next, we're going to take a look at the exclusive OR gate, or XOR. XOR, the symbol is different. You have a dual curved line on the input side. If you'll look closely, you'll see there's an extra curved line on the input side. It also means that it is exclusively OR, which means if you have one or the other input high, you do have an output. If you have both inputs low or both inputs high, then you do not have an output. Let's take a look at that truth table. The top line says that input 1 is low, input 2 is low, and we have no output, so the output is also low. Line 2 of the truth table says that input 1 is low, input 2 is high, and we do have an output. Line 3 says that input 1 is high, input 2 is low, and the output is high. Line 4 says that input 1 is high, input 2 is high, but output is low, which is different from an OR gate because this is exclusively one or the other, but not both. This drawing shows that if you have a low input, you have a high output. This image shows that if you have a high input, you have a low output. Inverters are very simple. Let's do a quick review of what we've looked at today. We started with AND gates, which is the equivalent to a series circuit, and both inputs must be high in order to get an output. Next, we look at the NAND gate. The NAND gate is a not AND gate. The output is inverted to the AND gate. The small circle at the end of the gate indicates it's the same as an inverter. OR gates are the same as a parallel circuit. Uh, Either input or both must be high in order to get an output. We also looked at a NOR gate, which is a not OR gate. The output, of course, is going to be inverse of an OR gate. There must be a small circle at the end of this symbol, which is the same as an inverter for the NOR gate. The XOR, or exclusive OR gate, is the same as an OR gate, except the output is not high when both inputs are high. It is strictly either one or the other in order to get an output from an exclusive OR gate. The inverter is a triangle with a circle on the output end of it. And all the inverter does is it inverts whatever signal is coming in. So if you get a high in, you get a low out. If you get a low in, you get a high out. Fairly simple.